Okay, so we're just going to mark that one picture equation, which I gave you for homework. I don't think I gave this one to you for homework, but regardless. So, right. So we look at the reactants, and we have 2 copper, right? We have 2 oxygens, 2 atoms of oxygen, and we have 2 compounds of copper oxide. Right? We can say it's a compound, or we can say it's a molecule. A molecule is the smallest part of a compound. So we have 2 coppers in the product side, 1, 2, and we also have 2 oxygens, right? Altogether, we have 2 molecules. All right. So if I have to form a chemical equation for this, if you are not muted, please mute yourself. Then I would start with Cu, right, which is copper. And I say that I have 2 coppers plus 2 oxygen. Oh, I see someone has answered me in the chat. Yeah, so 2 coppers plus 2 oxygen, which gives me, is that right? When I put the 2 before the oxygen. That's actually incorrect, right? It's supposed to be a subscript of 2. Why do I put the number next to the letter? Because that tells me how many atoms there are in one molecule, right? So remember that this is just one molecule of oxygen. All right. And lastly, I get copper oxide, right? And I have 2 molecules of copper oxide. Right. So whenever I have more than one molecule, I must put the number before. I must put the coefficient. And we have Cu, good Gabby, CuO, but now we don't put the 2 in this. Why don't we put the subscript of 2 next to oxygen? Because we look at one molecule, and in one molecule, there's only 1 oxygen and there's 1 copper, right? Whereas in this molecule of oxygen here, there were 2 atoms of oxygen. All right. Okay. Moving on, if I have to make a word equation for the above chemical equation, well done, Gabby. It's copper plus oxygen, which gives me copper oxide. Right. Okay. Guys, quickly look into the participants and tell me who is not yet in class. Well done, Christopher. Okay. All right. So moving on to the next thing that we're going to talk about today. Just give me a second, guys. I just want to see who's here and who's not here. Kayla isn't here as yet. Okay. AP342. I think that's Michael. All right, so balancing chemical equations. So we worked on picture equations before, but now we're going to learn about a new thing. So remember I taught you guys about balancing equations. Do you guys remember what I said about that? I said something about how energy cannot be created, nor can it be destroyed, but it is transferred. So what does that mean with regards to a chemical equation? Does anyone remember? It has to do with the number of atoms. No one? Okay. So, yes, Lee says that you do remember. The atoms are just rearranged. The number of atoms stay the same. Well done, Christopher. So, if I have 2 copper atoms here, then I'm going to have 2 copper atoms in my products as well. But it's rearranged. It's like taking a puzzle, right? You have all the puzzle pieces in one little bag at first, but then you rearrange it to form the puzzle at the end. So they don't look the same. The reactants look different from the products. So the instruction here is write word equations for the following chemical equations and balance them. So we need to balance these equations. When I say balance, I mean that the same amount of atoms that are in the reactants must be in the products as well. And we're going to do examples of that. Note 5, you may not add a subscript to a compound, only coefficients may be added. A coefficient is a number that comes before the compound. Right. Okay. Right. So the first thing we need to do in balancing equation is we need to draw a table, right? So if you're writing it on a page, you're going to write the equation on the top and you're going to draw a table underneath. The table will include all the elements. Notice how I'm saying elements and not compounds. The separate elements will have their own column. Can you see that in this chemical equation we have copper and oxygen, right? So in the reactants portion, we have one column for copper, one column for oxygen. Same thing, if I look at my products, in my product table, I will have one column for copper and one column for oxygen. All right, so all we need to do when we draw this table is we need to count the number of reactants and the number of products. So how many copper atoms do I have as reactants? I have one, yes. And how many oxygen atoms do I have? And we all can answer this because it's very easy. Good, Gabby. There are 2. Can you guys see that subscript 2 tells me that there are 2 oxygen atoms here, right? Well done, Michael. But in the products, how many copper do I have now? I have 1. Well done, guys. And oxygen? I have 1 as well. Christopher said, isn't it a diatomic molecule? Very good question, Christopher. So oxygen, chlorine, fluorine, bromine, iodine, all of the diatomic molecules, they only stay diatomic when they are alone. So can you see oxygen is alone on its own, right? When oxygen is alone, it will always be diatomic. It will always have that 2 next to it, right? But when it's combined with another substance, such as copper, then it loses that the diatomic atoms, right? All right, so guys, is this a balanced equation? Do I have the same number of elements on each side of my reaction? Exactly, I don't, right? So what do I need more of? I have 1 copper, which is fine. But oxygen in the reactants, I have 2. And in the products, I have only 1 oxygen. So yes, I need 1 more oxygen, right? In order to balance this equation. So this is where the interesting part comes in. If I want to add 1 more oxygen atom into the products, remember I said that you can only add coefficients. You may not add any subscripts, right? A subscript is a number that comes after the symbol. So if I can only add a coefficient, which is the number that comes before the molecule, I have to put a 2 there, right? Why do I put a 2 there? Because if I put a 2 before this, now I have, let me just draw it quickly. I have 2 times 1, right? Remember there's an imaginary 1 here. And I have 2 times 1 copper as well. Okay? So when I put a 2 there, I immediately change my number at the bottom. Now I have 2 oxygen atoms. And how many copper atoms do I have? If I put a 2 before copper, I also have 2. Right. Now, let's just tally up everything here. So I still have 2 oxygen atoms on the reactant side, and I have 1 copper still on the reactant side. Can you guys see that? What is it balanced now? Is everything fine now? What's missing? Tell me the element that is missing, a number. Yes, there's only 1 copper atom in the reactant, but there needs to be 2 copper atoms, right? So what do? We add a 2 before the copper in the reactant section, and then copper change, and then we change everything at the bottom, right? So copper changes, we still have the same oxygen, still have the same copper in the products, and still have the same oxygen. Now we are fully balanced. Can you guys see that? So until you don't come to the same amount of products and reactants, you are not balanced. Okay, but just say, we don't always need to have the same amount of, like, if there's 2 copper here, there don't need to be 2 oxygen on the other side, right? But if there's 2 coppers in the reactants, there needs to be 2 copper in the products. Let's write a word equation for this reaction. So you guys already gave it to me before. We have copper plus oxygen, which gives me copper oxide. All right, let's do another one. And I promise we're going to be doing many. And the reactions that I give you now are like 80% of all the reactions that you need to learn. So if you feel a little bit concerned with regards to how many you're going to have to learn, just know that all the equations I'm teaching you now is what you're going to learn for your exam. So I'm not going to give you new ones per se, right? So let's look at this equation here. I'm not going to tell you what this is. Can anyone tell me what the name of this compound is? MgO. MgO. It's magnesium oxide, right? Good. Yes, well done, Kian. So we take magnesium, we add oxygen to magnesium, and we end up with magnesium oxide. But in this reaction, what's happening is that we're taking magnesium oxide. Magnesium oxide, by the way, is like when you light a firecracker, okay? Then magnesium reacts with oxygen, and that's how you get that huge, like, white mass, or the sky lights up with colors, right? So in this case, we're taking magnesium oxide and we're breaking it up into magnesium and oxygen. And remember what I said about diatomic molecules? When they're on their own, like oxygen, they always have a 2 next to them, right? So let's tally this up. MgO is now my reactant, right? So what do I have here? I have 1 Mg and 1 O. But now I go into my products and I have 1 Mg and I have 2 O's here. So is this a balanced reaction? Why or why not? Give me reasons. What is unbalanced? Which element? Yes, well done, Lee. So I need to make sure that if I have 2 oxygens in my products, I need to have 2 oxygens in my reactants as well. So in order to change that, I need to go to my reactants and I need to add something. What can I do, guys, to bring me to 2 oxygens? What can I do? Write down the chemical formula. It's just like the previous example. Well done, Gabby. So Gabby says add 2 before MgO, right? Remember, guys, I cannot add any numbers next to the atoms. I can only add them before, right? So if I add 2, now everything changes. How many magnesiums do I have now? 2, yes. And how many oxygens do I have in my reactants? I have 2 as well. But now I have 1 magnesium in my products and 2 oxygen. So I'm nearly there, right? I need to do one more step to get me to a balanced equation. Just a second, guys. Right. So what is imbalanced here? And I want answers from those who are quiet. Let me see who's not answering here. Yeah, I want Michael to answer me, Sibu, Kayla, Amy. Right, exactly, guys. Magnesium is unbalanced, right? So there needs to be 2 magnesiums as well on the product side. And all I need to do is I need to add a 2 before my magnesium in the products. Yes, Michael? Thank you for raising your hand, by the way. It's really cool. Do you have a question? Okay, so guys, when I put a 2 in the products now, I'm left with 2 magnesiums, 2 oxygens, 2 magnesiums here again, and 2 oxygens as well. All right, very simple, very easy, and requires practice. It's basically like doing maths, but I think this is the fun kind of maths. It's equations, but it's not like the kind of equations you do in maths per se. It's more about, you can literally draw these atoms and molecules. Okay. All right, let's do this one here. This one is, we take hydrogen gas and we take oxygen gas and we get water in the end. Take that away. All right. Can anyone tell me why H has a 2 here? Why does H have a 2 and O have a 2 as well? And I want everyone to try to answer this, because this one's easy. Why is it that H has a 2 and O has a 2? Because they are diatomic molecules, right? So when H is alone and O is alone, remember, have no fear of ice cold fear. All of those elements are diatomic. But when H bonds with O, right, or hydrogen bonds with anything, it loses that diatomic molecule sometimes. All right? Can you see on this side, oxygen has lost its diatomic molecule? Yes, well done, Mo. So let's tally this up. We have 2 hydrogens, right? We have 2 oxygens. We have 2 hydrogens as well here, and 1 oxygen. So the only thing that is imbalanced here is oxygen. Okay. What do I need to do to bring oxygen to a 2 in my product section? What can I do? Type out the chemical formula. Just try. Remember, I'm going to give you a clue. I cannot add a number after, but I can add a number before. Gabby says put a 2 in front of the H. Okay, let's try that. So Gabby says we should put the 2 in front of the H, and if I draw this and I show you guys how it's multiplied, I must take the coefficient and multiply it by all the subscripts. Right, so here's a 1, right? So now I have 2 times 2 is 4 hydrogens. Remember, we done this when we were doing ratios. I taught you guys how to multiply. And 2 times 1 is 2 oxygens here. Right. Then on this side, I'm just telling everything up, 2 and 2. Okay. What is imbalanced now? Remember, Gabs, I can't put the 2 behind the O. I can't put I don't know if that's what you're talking about. Yes, hydrogen is imbalanced, okay? So how do I bring hydrogen to become balanced? I need to bring this hydrogen to 4. Yes, so how do I do that? What can I do to the reactants? Think about it, guys. Trust me, all of you know this. All of you know how to answer this. Yes, Christopher says times it by 2. So times what by 2? Write down the chemical formula. Remember, I'm working with this hydrogen over here. And I need to bring that hydrogen to 4. Well done, Christopher. That's excellent. So what Christopher's saying is that we just put a 2 before the H. right? Because guys, remember, we can't put a number next to H, but we can put it before H, right? And now we get 2 times 2, which is 4 atoms of hydrogen, 2 atoms of oxygen, 4 atoms of hydrogen again, and 2 atoms of oxygen. Are we balanced? Do we have a balanced equation? Yes, yes, we have a balanced equation, right? Okay, guys, just give me a second. I'm just getting a bit comfortable here on my seat. I'm actually sitting on my bed and I get uncomfortable sometimes. All right. Okay, moving on. So this is the balanced equation for water. Now you guys know, right? Water is actually two molecules of H2O give me a complete water equation, right? So let's put this as a word equation. I want Amma to try and answer this one. So read the reactants first, then read the product. If anyone else knows the answer to this, sorry, ma'am, I don't understand word equations. Okay, so in order to form a word equation, right, guys, we need to look at the reactants, name them, and look at the products and name them. That's literally what you need to do. So if I have H here, I start off with hydrogen, right? Plus, this is oxygen. And I end up with, as Michael is saying, hydrogen oxide. Okay, guys, moving on. Yes, well done, Michael. Okay, so this is another equation here. You guys are going to help me balance this out as well. I am going to give you 2 minutes, and all of you need to try this. If you have a pen, actually, you should have a pen and paper close by. So grab a pen and a paper and write this equation down and do it. I'm giving you 2 minutes. No, the numbers don't matter. Good question. As soon as you have the answer, type it to me on a private chat.